slightly more complex usage and a few tricks. And I will even touch upon something that is not used so often, but can actually take your plotly plots to, one could say, another level of interactivity, which can sometimes bridge the gap with some more complex application. It doesn't go all the way, but sometimes that can be enough to already get you where you want. So without further ado, let me start notebook 2. We import the libraries of interest, and we have seen up until now plotly.express, which is really the high-level library. And we see that what we tend to do is that we play around with the high-level library to create the larger plot, and then we fiddle around with the layout and trace element to change some things. And we can have a sort of, let's say, a middle layer between this very high level call and then fiddling around with a low level structure of the data. And that's what graph objects is for, if you will. That's a form of low level API that lets you directly create traces one by one rather than in a very high level abstracted manner as with plotly.express, which can help you create many at once. So here is again a small example. So plotly.graphObject is usually called GO. I here create some data, so I have a number of months there, and then some temperature. The high and low for 3 years, okay, 2000, 2007, 2014. I create my figure now with geo.figure. So this is the whole figure object that we have played around with up till now. You see here, if I print the fig, it's a figure object. But now we create it, let's say, empty, and then we are going to add element to it one by one with, here you see the add trace function, all right, method of it. So I add trace go.scatter, so it's also a scatter trace. And then you give the X and the Y. And because it's relatively low level, you actually have to be much more manual about what you're going to give. You can't directly map columns of data frame to the different elements. You really need to give the actual vector or array that you want to give there. Okay, so here the month, here the high temperature, I have to give it a name. That's the name that this will have in the legend entry. And then you see here this line equal dict. So if you would remember the structure of a trace, you remember that we have this marker and it points to a dictionary which set up the color and the type of symbol. Well, that's basically the same idea, because when I do that, I say that this will actually be a line trace. Okay, and we here set up manually that this will be like a firebrick colored and width 4 and so on and so forth. So you see, I very manually set up a trace there that will be added to the plot. And I do that element by element. Okay, you see here I can make it a dashed line, right, by just setting an element in the dictionary of line. I do this for all of them. And then I check also the layout. I set up a title, an axis and y-axis title, as we have done up until now. And then you see that with this, I have built a whole figure, right? It's just that before we did that in a single call, and now we just show a way of doing that in a very manual way. Of course, up to a point, if that was all organized in a single big data frame with the proper associated, column for high and low and for year, we could have done that in the same way, just using a plotly.express call. Okay, it's just another way of creating these, and it's useful to know both because depending on the structure that you have your data in, you may prefer to use one and the other. Also, one thing that we very often do is that you might create a first figure. I think I show that down the line, but you may just create a first figure with the plotly.express, and then you can add some trace on top of that, on top of the existing figure. You can, for instance, if you have a scatter plot, you can add a little couple of lines on top of it using this add trace and giving these as a go trace. All right, so that's it's useful to know both because this gives you more freedom in how you compose your complex figures, basically. But yeah, because from there, if you will, the structure of these figure is basically the exact same as to what we have seen up until now, right? So we have still a figure that is composed of a data element and a layout element. The data element is composed of a number of traces, and each traces correspond to this different call where we have these X and Y. You see that here they actually appear explicitly and not in the compressed version. I think this is because they are created directly through Geo rather than created through plotted express. And with the different, again, same element, everything that you've given up to now. All right. And as we have done before, one can go around and play around with this element and change them. Again, some sort of a silly example there. You see that I can go for the first data element. So that's my first trace. That's this one here, the high 2014, and change the line color to purple. Okay, and as you see here, the high 2014 line color is now purple. This is a bit silly. We can do something that may look even sillier, but we will see down the line can actually be also quite useful, quite powerful, is that we have for all of them an attribute that's called visible, which we can set to true and false. That's basically what happened when you click here. You set something visible to true and false. And so here, you see, I set it to invisible, and that's here. And you see that when I do that, it's yeah, it's not even in the legend anymore. That can be a bit silly to do that, but we'll see later on that there's a way to actually, for instance, create and add buttons or sliders or drop-down menus that can let us manipulate these visibility, toggle this visibility thing so that you can have some button that automatically let you make some figure element appear and disappear. And sometimes that can be a way to sort of make the figure appear more interactive than it actually is, or make something a bit closer to a dashboard without actually going all the way to a full dashboard. So that's still a trick that I think it's worth knowing about. And also, last but not least, something that we have seen already also, we can change all traces at once by saying update traces, right? Which now will impact all traces, and all traces will see their line color set to green. Also something that sometimes can be useful if you want to quickly change a lot of stuff in the plot, in the field of the plot, and so on and so forth, without having to build the whole thing from scratch. All right. And so, as I've said earlier, we can combine Plotly Express and Graph Object element together. So here I grab a little bit of data that's very simple, finest data. And you see that I create my basic here figure by just calling px.line to show the date versus the open, so that's one of the column. And then I can add on top of that two traces that I do using the low and the high, so that I have now these different elements. And if I zoom in, you see here the open, the high, and the low. The open was added with this first call there, and then I added two traces on top. All right. So we can sort of play around as we want there. Now, a lot of a lot of then this manipulation of element in using this Go really looks very much like what we did with the scatter when we try to change things after the fact. That is, when we call scatter, we have lots of arguments there, which we can set up to control the different color that we're going to create different traces and to set up the overname and so on and so forth. It's very much high level. And with Geo, it's a bit more finicky because we have to create our traces one by one. We cannot automatically map color to something like another column such as species or sex or something like that. We have to do that manually, and we have to map colors manually, symbols manually, and so on and so forth. So it's a bit more finicky. That can take more time, but that can also give us a tighter control on some elements. So for example, here, if I want to play around with the hover, I will show you a few methods that we have to have very precise control on what we show here, okay, in the hover label. So I create a scatter. I have my X, my Y, mode is marker color is gray. And then you see here, rather than saying over info or over data, I say hover template. And if you would remember again the structure of our of what we print here, you see that here that's actually part of what we have there in the data system. And if we look at this a little bit, you see here this little %z and so on and so forth. That's how the template link data and text. So here, that's what it can look like. For instance, I say species, then a bunch of tab, and then here, %, and then here text. When I write this, that means that it's going to want to look at a text argument there, and it's going to use, so for the first point, it's going to look at the first element in the list that I give here, second point, and so on and so forth, right? So you need to have a relatively precise map there. This takes here a list. Here you see the list of the species. Then here you see I give my X, I give my Y. There's one trick to it, is that this here is given using HTML syntax. Okay, so that's why, for instance, I don't use \n, but instead I use this line break here, which is HTML. And I think that here these tabs are actually not going to work that well. I should use the HTML tab instead if I wanted to have more precise control over the number of white space that appears there. All right. But then that also actually offers you plenty of opportunity because you can put all sort of HTML stuff in there. All right. I think that you still have to use relatively basic HTML. I've not experimented with fancy things, but that offers you a bit of control to the presentation. So you don't have to always have this very simple thing where you have something equals something else, something equals something else, and with everything sort of not properly aligned, so it's a bit complex to read and so on and so forth. You can redecide, you can array, you can create white lines in there. Well, you see here my tab are a bit silly, they are not perfectly aligned, but you see that you can have stuff that present a bit better, and you can have a tighter control as to what you show, what you don't show, and how you choose to show it. For example, here you see I show the full species. Okay, Gentoo, penguin, Pygoscelis papua, which takes up a lot of space. Whereas here I choose to give to the text specifically just the first word of the species. And so this shows as the Adelie Gentoo chinstrap, which is then smaller and creates less visual clutter when playing around. Okay, so far so good? All right. And so now from there, one thing to consider is this little text thing, because you have basically here in there, you have the X, the Y, and text. And so here then you can also use this text to create a whole like whole sort of element. You just have to remember that you have to kind of create them using this HTML syntax. So here I give a small example where I create a cd function that takes a row in my data set and then return like a whole set of text with just first giving the species, then the sex with some sort of NA treatment with a little bit of thing so that if there is a comment and prints the comment, and then I make the label for each row and I give that to text such that I can include that in my over template. So you see I can have now a template that becomes relatively adaptable and will show exactly what I choose to show. Will show sometimes you see a comment if there is a comment and will not show anything otherwise. And there are somewhere, yeah, somewhere the sex is NA and then it's shown without any, any proper error and properly shown as NA. Okay, so that's something that again demands a little bit more work from you, right? But gives you a tighter control to get the precise visual and interaction that you want with this other label. So it's again, I think a trick that you are not going to use necessarily every day, but when you want to get something nice to use, nice and usable, it's actually quite useful and nice to know about. So far, so good. No questions? Okay, then let's go and have again a second exercise so that you can get to practice a little bit with that. So the exercise is about some ataxic data. Okay, so you have a set table where each column corresponds to a set of positions there, all right, on the genome. It's just really a chosen window there. And then you have a number of columns, each corresponding to an experiment with value corresponding to a, let's say, normalized number of read seen at these positions. And then I generate a basic figure here. You see, I create my figure, and then for each sample in this column set there, you see that I create a simple scatter trace where the X correspond to the position and the Y correspond to the sample, right? So this is my here basic figure there. Okay, as you can see, I mean, okay, the data is there, but it's not extremely useful right now. So you have to now add some element to it. So for instance, add some proper trace name. Okay, so play around with how we create a figure to change that. Then make sure that the replicates are the same color. So you see here, this, for example, THDIT531 appears twice, underscore T1, underscore T2. Same thing here, same thing here. So if they were the same color, that would be, again, a bit easier to understand a little bit what we are seeing here, to see eventual color or to see if the replicate look like one another. Change the overt label also so that we have a position that appears in a plain integer, because right now you can see that it appears with this M, so it's in million, okay, and that's perhaps not what we want to have. So play around with that, and then extra, if you have the time, you can play around with group legend items, but that's extra thing, okay? So I'm going to calling. Our goal with this exercise was to make this plot of the profile of reads for different sample a bit more useful for the purpose of data exploration, basically. The first thing that we want to do is to say, okay, we have a number of traces here. They come from different sample. Well, we can just try and make it so that the trace name reflects the sample name. Okay, and for this, we can just use the name argument there when we create the trace. And what this will do is that will change also the name of the entry in the legend, so that now we can know what is what. And we can also have, you see on the right, the name of the trace that appears on the right of the hover label. Okay, so that when we hover, we also know what we are pointing to, which sample we point to. Incidentally, there was a question by Balash about this, about how we could perhaps make this disappear, and I've found two ways of making that disappear. So you can look in the chat if you're curious how we can also remove that in case we don't want to have this information in the hover label. So that was the first part. The second part is about realizing that you see we have some replicates there, okay? T1 and T2 for these different conditions. And we may want to link them together. Perhaps we can give them the same color or close color. So for this, the way that I propose to do it, I made a small function there that basically takes the sample name and then just remove this underscore T1 and underscore T2 there, and this gives me the actual sample name. And then I made a small dictionary that links this sample name to a specific color. Here I use a very, very simple color scheme, but you can use whatever you feel is appropriate. And then here in my for loop, I change this line color, and I basically give to line color the condition associated, well, the color associated to the condition, and I get the condition by giving the simple name because that's what I have here, to then remove this underscore T1 and get the corresponding color. And so what I get from this is now that thing, which becomes now a bit easier to interpret. Here, provided we see that actually the three different samples are not so different from one another, but we kind of start to have, you know, an easier way of kind of trying to go and see what is what in this data set. And then we see also that when we hover there, you see that the first element, 37.x68 and so on and so forth, that's the position at which we are at, right? And that's not very, very beautiful, and not that doesn't really correspond to what we would expect for a position on a genome, right? Especially since here it's actually just showing up to like 5 elements after the comma, whereas we would want to have 6 if we want to have the precise position that we are at the moment. So we would have to have something like this instead of that. For this, I play around with the hover template. And so that's the hover template that I created there. Position, average coverage. I give here the X. And I could just give it like, just like this. I could give it like that. I just went a little bit farther, and so that if you do something like this, so you had this here column and then comma, that's actually going to put a comma every 3 digits, which makes also the reading of this long number easier, right, visually speaking. So that was a nice trick that I didn't know about before, but I learned and I find it useful. So you see here, that is what we have for all of these traces. Okay, so with that, we have played with the name there. We have played around with the color, and we have played around with the template. And then there was the little extra one, which asks you to first perhaps go and read a bit and look a little bit at what how the website of Plotly worked, okay, and understand a little bit how you could sort of use that for yourself. So you see that our website is very much example oriented. And so you have to go through a lot of the example oftentimes before you kind of find what is applicable to you. So it gives you, like, it demands a bit of time to kind of get there and find what you need. But then once you have that, it always comes with example of code, and that makes it a bit easier for you to adapt it to your own case. So I think it's quite an okay website when it comes to documentation of libraries. Here I am going to show you the solution. Well, I have the same thing as before, but you see that now I have a legend group and legend group title text for which I give for each sample the associated condition name, but using again my remove replicate function. So now, for instance, NVP2 T2 will go to the group NVP2. Okay, and what this gives me is this now organization of my legend, which I think you'd agree is relatively useful. Not only because you can quickly see what is what, but also because now the sort of thing that we can do where we make them appear or disappear works in a grouped way. Okay, so we have now grouped these elements, and so we can make not one line, but the two line appear or disappear together. Okay, all right. So everything good with this correction? Any questions? Okay. So then if everything is good, I want to show you a little trick, which I find quite useful. Perhaps you'll find that super nice and will want to use that always, or perhaps you will find that super complex and will never want to use it ever. But I want to show you just so that you actually make up your mind. So here you see I create the same thing as before. That's really the plot that we have seen before with these lines there. But then afterward, you see that in my layout, I update something. I use here this very complex structure to add update menus there and add some buttons. Okay, so I had an element of type button. And you see that now this button, you have here one button, two buttons. Okay, you have their label there, high only, low only. And what they do is that they update the trace. So you have two type of method, the update, which update the traces, and update layout, which can update the layouts. So as we have seen, there is always a traces and layout structure of these. And with these update method, we can update some of the attribute of the traces that we have added there. So you see here, we have now with these them appearing there, where they are exactly is decided based on that, X and Y position in terms of axis. So 1.1 is slightly above 1, which would be here, okay? And here 0.11 would be at about 10% inside on the X axis. That's why it appears here. And what it does here, you see it changes the visible argument of the trace. So you may remember my silly example from before where I tweaked this with this, set the fig data visible to false to make it disappear. So here that's what we do with the buttons. The button play around with that. And basically what I say is that when the button is clicked, you set visible to this. So this, if you're not extra familiar with some of the Python list syntax, here by doing that, I get this true, false, true, false, true, false. Okay. So that means that this will be mapped to the different traces that are there, so that the first will be then true, means visible. That one will be invisible, this one visible, this one invisible, this one visible, this one invisible, right? So I just toggle which one is visible, which one is not. One every two is visible. So see here I say high only, then here I say low only. I reverse false, true, false, true, false, true, instead of true, false, true, false, true, false. And now then what I have when I do this, I still have the same thing as before, but I also have these two additional buttons. One which when it's clicked, only the high are kept and the low are not visible anymore. And one, if I click now this one, now only the low are kept. all the high are not visible anymore. So far, so good? All right, so the syntax is a bit ugly, and sometimes you need to fiddle a little bit to have the exact thing, feel that you want to have to move this button to exactly where you want them to go. But that can give you a little extra layer of interactivity there. And here I show it with button, but you can also have drop-down menus to choose several options, or you can also have sliders. Okay. And so now we come to a small micro exercise where I ask you to just try and change something in the code above to add a third button which shows all trace all over again. Because you see that here, because they disappear from the legend, I am actually kind of stuck to only showing the high and the low. So I would need a third button to make everything visible again. All right, so your turn to work. Let's give it 3-4 minutes, I think, for you to feed around with that. Please use the little green tick to let me know when you're finished, and then we are going to correct together. Recording again. Okay, and so we see that our task was to kind of take this example and then add something that would make everything visible again. So for that, we can sort of fiddle around, play around with this, add a new button, okay? First, I'm going to just just change the name, everything visible, and just see, okay, so far so good, this thing works. Now, of course, we want to make it so that it actually does something interesting, because right now we have the same thing as before. And so for this, what we can do is make it so that we have six times true. All right, so that we have everything set to true. And then here we have low only, high only, everything visible. All right. So I think that this was the solution that all of you have used. And you can see that the syntax is super ugly if you want to start to play around with specifically where you put the position and what you do if you want to start to fiddle around with many stuff at once. It can be a bit complex, but for relatively simple stuff, it's actually not too difficult, especially if you work your way from existing examples. From there, it is 11:52. So we are going to go on our lunch break soon. But before that, I would like to quickly present the project that we propose. So when we come back after the lunch break, we would split into a smaller breakout room, and you will get an hour to work on, or yeah, perhaps half an hour, 45 minutes to an hour. We'll see how long it takes to work on a bigger project using Plotly. And I have three to propose you. The first is K-means. So basically the idea is we have some data. Here you see that it's handwritten digits. That's a very classical data set when we do some clustering or some classification. And if you have sklearn already, you can actually import them for yourself using these lines of code. But otherwise, I've already pre-computed a PCA and a UMAP on this dataset so that if you don't have scikit-learn installed, it's okay. You don't need it. The important part is that we would like to visualize this data set in its reduced form, sorry, so as a PCA or as a UMAP. So for instance, we can see here the PCA result for it. We can see that there is some amount of segregation between numbers, but it's not perfect. And here I show you a small scatter for the UMAP. We see that there is, here this UMAP visualization is quite nice for this simple data set. And we also see that we have then the labels. Here's where they are stored. So that's basically because we have here some numbers, digits that are handwritten. Well, some of them are 0 or 1 or 3 or 5, and this is stored in this here. And I have also created a small implementation of k-means, so the simple clustering algorithm, right? And that can let you take, for instance, here the PCA data as input, and then you do a k-mean. So you try and cluster this data into 10 clusters, all right? And hopefully then perhaps this cluster actually correspond to the original label, all right? And that can be checked with a simple cross tabulation. There, for example, we see that um, it's more or less the case. Like, for example, here, the label for almost all went to one given cluster. Of course, the number of the cluster is arbitrary because K-mean cannot know what is what. It can just group things together. But it's not exactly perfect. So what we would like to do is make some sort of interacting visualization that helps us show this UMAP or PCA data and try to see a little bit how, where are the data points, what is their original label, and what is the cluster associated to them by the k-mean. Okay, so we give you here a few idea about what we can do, and also a few extra stuff to do if you want to start and try and add some additional things. And of course, that's just ideas. If you have more ideas, more stuff that you would like to add to make it a cool and informative visualization, go for it. I propose here some correction also just in case you want to see how I propose to do that. So that's the first project. The second project is here about plotting some fossil data. So I grab some fossil data from a public database. So each line here is a fossil. There is a lot of information in this. There's many, many columns. But what I'm quite interested about is their species. So you can get species, genus, or subgenus for each of these. This correspond to proboscidean. So that's elephant, and also things like mammoth and so on and so forth. So old extinct genera of elephant-like animals. And we see that each, sorry, forgot to run this first line. Here we see that each of these fossil record are linked to an age, so that each fossil has a maximum age and a minimum age. Okay, and we can sort of see if we were to map the number of genus found at any point in time. So along the x-axis, I have million years. All right, so that's present here, and this is now in the past. We can see that there was about 10 million years ago, there was like kind of high point where we had many extinct genera that were present at the time, but nowadays they are most of them extinct. All right. And what we have is not only the age of these fossils, we also know where they are. We have a longitude and a latitude for each fossil. So we'd like to visualize where these fossils are and then eventually where they are with respect to time. So for this, I give you a little data set containing the coastlines so that you can plot where they are on a small map in a simple way. I give you the trick on how to make lines not continuous, just in case you want to have fun with that. And so your goal is to sort of show these fossils on the map and make it informative, perhaps make it, what I propose to do is to add a slider so that you can change and have a window in time basically of which fossil you want to show and so on. So that's the second project. And then the third project is very biological. It's about making a volcano plot. So I give you here some result of differential expression analysis. So given as a very classical dissect2 table. Okay. And so you see that you have each row being a gene, okay, with this ensemble gene name. And then we have base expression, but more important, log fold change and adjusted p-value. And so your goal is to make a volcano plot visualization. So volcano plot has log4 change as an axis and the p-value or adjusted p-value as a y-axis, but not just the p-value, but the log of the p-value. And we often show, as is done here, for example, a little line corresponding to some sort of threshold on the p-value, and also we can color differently the genes that are significantly different and not, and so on. So that's kind of what is asked there. Kind of give you a little idea about what you can do, what you can change there. And of course, again, that's just to give you ideas, but you